It's generally agreed that capturing the impact of user interactions on the data in a system using provenance is a good thing to do. However, for the non-specialist, this can be a tricky task. It will require knowledge of certain formalisms to specify the data of interest in a system, and even with that knowledge, it can still be difficult to actually extract that data from a system. Finally, it can be difficult to query the data stored in order to ask certain questions of the information gathered. At King's College London, we've developed a suite of tools, which we collectively refer to as ProvIt, which are designed to address these issues and allow a non-specialist to add provenance capabilities to a system. So let's imagine a scenario in which I have a group of researchers working on a set of Jupyter notebooks, and I want to use provenance to track the evolution of those notebooks. Specifically, I'm interested in the libraries that have been imported by different users. If I'm a non-specialist and I want to add these provenance capabilities to Jupyter, this might be quite a daunting task, and it might be quite daunting to go straight to the prov specification to work out how to specify which data is of interest to me. Instead, what ProvIt offers is a provenance authoring web app, which allows users to graphically construct what we call provenance templates, and thus specify data of interest within a system. Because it's a template, the user, alongside various concepts such as entities, activities, and agents, also specifies variables, which are placeholders for the information that's going to be captured from a system. Once a provenance template has been constructed, it's likely to be exported and stored in what we call a provenance server, which might have some backend for the storage of data, such as a graph database like Neo4j. The next challenge, therefore, is how to actually get data from a system and store it in a template server as dictated by the templates that are stored there. So, for example, with this imported template, how do we actually extract the language and library names of various imports from Jupyter to create a substitution for this template? Well, we can see there are various patterns within the data that we have that indicate where this data of interest is. So as a very simplified example, we could say that library names in Python are always preceded by the import keyword. So what we can do is we can actually specify a pattern which says that every time we encounter the import keyword, the word that follows it can be used as library name within a substitution. We also associate different actions with different matches. So for example, in the case of determining the name of a library, we need to actually extract some information. But in the case of actually determining the language used by a library, there's nothing to extract. Instead, it's simply the presence of the match which indicates that the language is to be Python. This is exactly the approach taken by the second component of ProvIt, which is a provenance client, which easily and interoperably connects with lots of different systems, in this case Jupyter, and once sent data from that system, we'll be able to parse it and construct substitutions for various templates automatically and store them in a template server. Once this information is stored, the final issue is how do I actually get my information back? How do I query for the information that's been stored? And again, for a non-specialist, this might be quite intimidating. They may think that they may be required to learn new querying approaches. But what ProvIt offers, its third component, is what we call query templates. And what this allows a user to do is actually pose their queries using the exact same format that you actually used to specify that template in the first place. However, in this case, any variables that are substituted with actual terms, so in this case we can see that the language and library name variables have been substituted with the words Python and pandas respectively, are actually used as search terms, and any variables that are left remaining are the values that you want to get back from your query. So if we specify a query here where only language and library name are substituted, but things like notebook name and author name are left blank, then we're intuitively asking if we can find those authors and the names of their notebooks that contain imports of the Python pandas library. We put ProvIt to work in practice at King's. We realized this actual Jupyter example, and what we did was we tracked the actions of a group of researchers analyzing a COVID-19 dataset. And we constructed in total 923 substitutions, an extract of which is shown here. What we can see here is 2 notebooks, initial exploration and description statistics. We can see 2 save actions, which have triggered a provenance substitution to be created and effectively transition a notebook from one state to another. And we can see that the current state of the notebook is defined by the inputs that are there. And again, here we can see important reproducibility information. We can see who imported what when, especially when this substitution is combined with others. And we can also see more complex things, such as common libraries. You're welcome to have a look at our ProvIt-enabled Jupyter environment, which is available on GitHub. Thank you very much.